Now exercise 5.18. The bob of a pendulum is released from a horizontal position. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at the lowermost point? Given that it dissipated 5% of its initial energy against air resistance. So let's first try to understand the situation with the help of figure. Right? See, here the pendulum, which one is with length L. So when it is placed in the perfect horizontal position, then we can say with respect to the lowermost point, it is at height h, which is equal to the length of the pendulum, and that is 1.5 meter. So when it is in the horizontal position, its total energy, that is kinetic plus potential. Kinetic energy is 0 and potential energy, that is mgh. Now when it is released from this position and when it reaches at the lowermost point, 5% of initial energy, so initial energy, that is mgh. So 5% of initial energy is lost against air resistance. It implies that when it reaches at B, its 95% energy is now converted into kinetic energy, because at the lowermost position the potential energy becomes 0. So entire potential energy will be converted into kinetic energy, but 5% loss is there. So we can say this thing: at position B, the kinetic energy half mv square, that is 95% of initial energy, and that is 95% of mgh. Clear? So here we can write half mv square, that is equal to 95 by 100 mgh. Now m will be cancelled. Now if we make v as a subject of equation, then that is equal to under root 2 into 95 into gh upon 100. Substitute the value of g and h, and then after solve it, then you will get v, that is equal to 5.3 meter per second. It implies that when your pendulum reaches at the lowermost point, then its velocity, that is 5.3 meter per second. Clear?